In this series, we're tackling the New York Times connection puzzle again. The challenge is simple to describe but tricky to solve. From a set of 16 words, you need to form 4 groups with 4 words with a common connection. What makes it difficult are the nuances of the English language, synonyms, overlaps, and subtle meanings that blur the boundaries between groups. This is my second attempt at building a virtual assistant to help solve the puzzle. A link to the first attempt can be found in the video description. What makes this second attempt interesting is the use of a specification-driven development methodology, providing a more structured and transparent way to design and build the assistant. Let's see how this process unfolds. In this project, we're applying the specification-driven development methodology to build a simple web application virtual assistant designed to help a human solve the New York Times connection puzzle. The foundation of this effort is GitHub's Spec-Kit, an open source framework intended to meet the principles of specification-driven development. What is specification-driven development? It is a software development process where specifications are no longer just guides but become executable artifacts that drive the build. The workflow starts with defining what needs to be built, the requirements and intent, then planning how to build it, creating detailed tasks, and finally implementing code, all structured such that the spec itself helps generate the usable implementation with the help from an AI code assistant. Our application has 2 key features: a web-based user interface and integration with a large language model, enabling intelligent support for puzzle solving. Building of the application is structured into 2 phases. Phase 1 focuses on building the web UI using stub code to stand in for the backend functions. During this phase, we define the project constitution, specifications, technical plan, tasks, and then build the initial components with GitHub Spec-Kit. Phase 2 takes these Phase 1 components as a foundation. Here we replace the backend stub code with functional logic that integrates with an OpenAI large language model to generate word recommendations for the puzzle. In this phase, we again use Spec-Kit to define the specifications, technical plan, task, and then build the enhanced components. For this project, we use GitHub Copilot in VS Code's agent mode, powered by Claude Sonnet 4 large language model. Here you can see how much time each part of the workflow took in Phase 1, from setting up the project and defining requirements to planning, analysis, and implementation. If you want to dive deeper into how each step works, check out the links in the video description. In working with VS Code Agent and GitHub Copilot, Phase 1 took about 145 minutes or approximately 2 hours and 25 minutes to complete. From all this work, we achieved a working web UI, sort of. There were some glitches, which I've come to expect for any agent-generated code. In the next few slides, I'll explain what were the issues and how I prompted the agent in guiding it to fix its errors, somewhat akin to guiding a junior developer. Here we see the initial manual testing results from Phase 1 of the web UI. The good news is that the web page opens and a puzzle file was successfully uploaded and the recommendation system was generating outputs. However, there were several issues. First, puzzle words were being used inconsistently in the stub functions. Second, the web UI was incomplete. Specifically, it did not show the history of previous guesses, which was a key feature. And finally, button behavior did not follow the specification. Buttons that should have been disabled and grayed out after indicating a correct guess remained active. To address these issues, I used VS Code Agent Mode with GitHub Copilot powered by GPT-5 Mini LLM to fix both back-end and front-end problems. The prompts shown in the table were used verbatim, including the small misspellings, which demonstrates the resilience of the agent in handling imperfect input. As a result, we accomplished the following. On the back end, we simplified the recommendation function to just return the first 4 remaining words along with the placeholder connection string and updated relevant unit tests to reflect this change. On the front end, we pointed out to the agent the incomplete implementation of FR008, which added the missing display of previous guesses at the bottom of the UI. We also updated the front-end test to match the revised interface. Finally, we fixed the button behavior, ensuring that the yellow, green, blue, and purple buttons are disabled and turn gray after being clicked, just as the specification required. The impact of these fixes can be seen in the before and after comparison. On the left, the initial UI shows only the correct recommendation with no history of guesses, and buttons remain active even after use. On the right, after directing the agent to make changes, we can now see a much more complete experience. Correct and incorrect groups are tracked, mistakes are displayed, remaining words updated properly, and most importantly, previous guesses are logged with both timestamp and color coding at the bottom. This aligns the UI behavior with the intended specifications. Overall, this represents a significant improvement in usability and reliability. Now let's do a demo of the Phase 1 Web UI. Remember, the backend services are still stub code that will be refactored in Phase 2. Alright, let's first bring up the backend service. So we'll start the backend service. Alright, looks like the backend service is up and running. Now we'll start the front end service. And it now looks like the backend service is up and running. So with that, let's open up a browser and we'll go to the page. Alright, as you can see, we now have the web page for the Connection Solver Assistant up and running. So let's initialize this with a puzzle file. And then we'll ask to do a puzzle setup. Alright, as you can see, we now have 16 words, and that, we haven't so far started, so there are 0 correct groups and 0 mistakes. Okay, so now we'll get our first recommendation, and again, this is just stub code, and the get recommendation will just actually retrieve the first 4 words of the words within the puzzle. So we'll just do get recommendation, and we can see that we now have 4 words. Again, this connection reason is just here for testing purposes. And then we'll say, all right, so let's just say this is correct, and it's the yellow group within the connection solver. All right, and you can see we've now updated the correct group counts, 1 out of 4, no mistakes, and that we now have our previous guess from that we had just done. So let's get the next recommendation. And again, this again is just getting the first 4 words of the remaining puzzle words, and this time we'll indicate that this is incorrect. So, before we go, if you remember, we indicated yellow correct in the previous recommendation, and now you can see the button is disabled. So we'll do incorrect here, and now it says this was incorrect, and that we have 1 out of 4 mistakes and 1 out of 4 correct groups. All right, so let's get our next recommendation. Again, it'll be the same 4 words. This time we'll say it's correct, and you can see we have now correct, and that we now only have 8 words remaining, and that 2 out of the 4 correct groups have been found. So let's just assume and finish the puzzle where it gets solved. All right. So, and again, as you can see, the previous buttons are currently disabled. Now we'll say this is the correct blue group. And now it says we found 3 out of the 4, and there are only 4 words remaining. We'll get the recommendation, and then we'll mark this as correct for the purple group. And now we've solved the puzzle. All right, let's try this again where we don't solve the puzzle. Again, we'll just initialize, get the same puzzle words, initialize it, we'll set it up. And again, this time around, let's just try, and we'll just say this happens to be correct, and it's the blue group. See, okay, it's recorded as being the blue group and that it's correct. So let's get the next recommendation, and this time we'll say it's a one-away error. And again, we'll see mistakes is 1 out of 4, indicating this is a one-away error. So we'll do the next one, and this time we'll say it's incorrect. So again, it recorded that as incorrect, and then we'll get the next recommendation. We'll say again this is incorrect as well, again, and then we'll get another recommendation, and this time we'll still indicate it's incorrect by saying it's a one-away error. And as you can see, we've done 4 mistakes and that the game is now over. So again, this demonstrates that the web UI portion of the connection solver assistant is working, and that now this seems like a good baseline where we can now start building on for phase 2, where we now integrate the large language model into the backend. The agent can do more than generate code. I asked it to review the front end and back end modules in the codebase and generate an architecture diagram. Using the simple prompt shown in the upper right corner of the slide, the agent analyzed the code and produced a mermaid diagram on the left side, shown on the left side of the slide, showing how the user interacts with the React front end and connects the front end to the back end, and how the back end manages the puzzle sessions and recommendations. The generated mermaid markup code is shown in the lower right corner of the slide. What's powerful here is that the diagram wasn't drawn manually. It was generated directly from the structures found in the code. All I had to do was a quick fix to clean up a couple of mermaid syntax errors, and the result was a fully functional architecture diagram, automatically created from the agent's understanding of the application. This really shows how agents can go beyond coding. They can analyze, document, and visualize your entire system with just the right prompt. To close off phase 1, let's look at some of the key experiences from this phase. First, specification-driven development is not a fire and forget approach. Human developer oversight is essential. For example, I had to clarify missing specifications, remind the agent to update status, rename API endpoints, direct the agent to fix failing tasks, and confirm recommendations. Second, the quality and completeness of the specifications directly impact the quality of the generated code. Inconsistencies in the backend functions, as noted in the manual test that I talked about a few slides ago, showed how gaps in the specifications led to weak implementations that needed to be fixed. Third, developer experience still matters. I needed to know when to let the agent fix issues versus when to intervene manually. Backend evaluation of the agent-generated Python code was straightforward because of my experience with Python. However, I was more dependent on the agent for front-end work because of my lack of experience with web UI development with technologies such as TypeScript, HTML, and CSS. I experienced a little bit more difficulty in working with the agent by not knowing right terminology to describe what needed to be done. Fourth, when working with the agent, I made frequent use of Git branching. Anytime the agent generated changes, I created a new branch for safety. If the changes worked, I simply merged the branch. If the agent's changes went off the rails, I simply deleted the branch and started again with a revised prompt. In the past, if I had spent hours manually creating or modifying several source modules and things still weren't working, I'd feel compelled to keep hacking at the code, mostly because of the time I had already invested. But with the speed at which an agent can generate code, that mindset has changed. Starting over isn't a setback anymore. It's just part of the workflow. That's a big shift in thinking. With the agent, rewriting code takes so little time that iteration becomes fast, flexible, and low risk. And finally, we must recognize that the agent will make mistakes. It's part of the process, and that's why structured oversight and iterations are critical. That wraps up phase 1 of the project. Next, I'll begin to work on phase 2, where we'll replace the backend stubs with functional logic and integrate with a large language model. Once phase 2 is complete, I'll update the YouTube playlist with the results. If you like this video, don't forget to click on the like button and subscribe to this channel. Thank you.